Hello to all students. In this video lecture, we are going to discuss mass spectrometry. Mass spectrometry is an analytical technique used in chemistry to determine the masses of different isotopes of an element, and also we can determine relative abundance of different isotopes of an element. So first of all, we are going to look at the definition of a mass spectrometer. It is an instrument, analytical instrument used to measure the exact masses of different isotopes of an element, and along with masses we can also determine the relative abundance of these isotopes. Let's discuss the working principle of mass spectrometry in detail. So first of all, we have to look at the diagram of a mass spectrometer, which composed of different components. So we are going to discuss these components and their working one by one. So first thing first, any substance which is solid, liquid or in gaseous forms can be used in this mass spectrometer. If the substance is in the solid form, then we have to make it volatile so that it can be used as a form of vapors in mass spectrometer. And if it is liquid, it is also vaporized, and if the substance is in gaseous form, then there is no need to vaporize it because it is already present in the gaseous form. Mass spectrometer is not only used for detection of masses of different isotopes, rather it is also used for drug testing, isotope ratios, carbon dating and protein identification. So the first step in the mass spectrometry is vaporization. So first of all, we are going to convert our substance into vapors if it is not present in the vapor form. In this example, we are going to take an example of neon gas, which is already in the vapor form, gaseous form. So substance is going to be transformed into vapor state. We are going to keep a very low pressure with help of a vacuum pump, and the pressure will be inside the chamber, which is vaporization chamber, will be 10 raised to power minus 6 to 10 raised to power minus 7 torr. As you know that our atmosphere has 760 torr vapor pressure, but we are going to reduce it 1 billionth of atmospheric pressure, which is going to be 10 raised to power minus 7 torr. So it is very low pressure inside this chamber, and the gas neon is going to be entered from a tube-like structure which is inlet. So this is the first step of mass spectrometer. Now we are going to move toward the second part. In the second part, we are going to ionize neon gas. As you know that neon gas has atomic number 10 and atomic mass 20. It is a neutral atom. It is also a noble gas. But we are going to remove electrons from the outermost shell of the neon gas and to convert them into positive ions. In the ionization chamber, there is a heated filament which is going to produce a beam of electron. These beam of electrons are going to fall on the neon gas which is present in this chamber. These fast moving electrons will convert vapors, gaseous form, molecule atoms into ions, and the vapors are going to be converted into positive ions. So this is the second step of the mass spectrometer. Once the ions, positive ions has been formed, now we are going to collect all these ions and form a beam of positive ions. So there is a third step which is known as acceleration. For acceleration and collection of these positive ions, we are going to use negative grid, which is going to have a voltage potential difference of 500 to 2000 volt. which is going to collect all these positive ions. This grid has negative charge and is going to attract all these positive ions towards itself. Now, all these positive ions of neon gas are going to be collected right over here in the negative grid. Now, these positive ions which are collected at the negative grid are going to be accelerated with help of accelerators, which has a small slot in the center, and these rays, these beams of positive ions are going to be collected in a single beam and in a very fast speed, moving through accelerator through a slit. So this is the third step of the mass spectrometer. Now the next step is deflection. For deflection, we are going to use magnets outside this tube. These magnets are known as analyzers. These are going to deflect this beam of positive ions. As beam of positive ion is moving at a very fast speed, it can produce a magnetic field, and this magnetic field is going to be interrupted by this these magnets present outside the mass spectrometer, and these magnets are placed perpendicular to the coming beam of positive ions. As these ions in the form of beam, when they fall or they pass between these two poles of magnets, the beam of positive ion is going to be deflected and start moving in a circular path. These positive ions contain 3 different isotopes of neon, and each type of isotope contain mass over charge ratio, and according to their mass over charge ratio, these positive ions are going to move in a circular path, and there is gonna be 3 rays which are going to be originate from the central beam. The next step is going to be collect all these beams of electrons. So there is a detector which is connected with the computer, which is also known as ion collector. This is going to collect these different types of ions falling on the surface of the detector with a different mass number, like this one contain mass number 20, 21, 22, because each beam of ion contain different mass over charge ratio and each has different circular path. So then this information is then calculated by the computer, and a graph is being established which gives us relative abundance of different isotopes present in the sample of the neon gas. So in this graph we can see that while falling, when positive ions moves from deflected from magnetic field, falls on the detector, it produces a small or minute electric charge. This minute electric charge can be detected by the detector, and it can be recorded in the form of a graph right over here. So we can see in the graph that mass number 20 of neon isotope has most abundance, which is 90.92%. It means that this isotope is falling with more abundance and it producing more electric charge right over here at this point. The mass number 21 isotope of neon gas has very minimum amount of abundance, which is 0.25%, while mass number 22 of neon gas isotope has abundance of 8.82%. So in this way, we can not only determine the mass number of an isotope of an element, and also we can determine the relative abundance of different isotopes of an element. These elements show a kind of spectrum of mass number, just like when a white light is passed through a prism and the white prism splits the light into 7 different colors. In the same way, when beam of positive ions passes through magnetic field and then moves toward detector, it is split into different isotopes according to their mass over charge ratio, and we can detect with the help of a detector and with the help of a computer. We can also use a mathematical formula to determine the mass number, and their circular path, and we can calculate their masses and their abundance, which is going to be m over e, or we can write m over z, which is mass over charge ratio, and every isotope has different mass over charge ratio, which is equal to h square r divided by 2e, where h is the strength of magnetic field, which is we're going to use right over here. E is the strength of electric field, which is going to produce right over here, and r is the radius of circular path in which these isotopes, ions of different isotopes, moves in a circular path. So if we keep the h constant, it means that we keep the magnetic field constant, then by increasing the strength of electric field will increase the radius of the circular path of these ions. Smaller mass over charge ratio means that smaller radius, larger mass over charge ratio means larger radius, and different radii of these ions fall on different location on the detector, with the help of which we can detect the relative masses and also their relative abundance. And that's all for today. See you in the next lecture. Until then, bye.